Alright, so in this video I'm going to be explaining biomedical event extraction as sequence labeling. So this paper in 2020. We introduced biomedical event extraction as sequence labeling, a joint end-to-end neural information extraction model. This model recasts the task as sequence labeling, taking advantage of a multi-label aware encoding strategy and jointly modeling the intermediate tasks via multitask learning. BSL is fast, accurate, end-to-end, and unlike current methods, does not require any external knowledge base or pre-processing tools. And it outperforms the current best system on the Genia 2011, but just 1.57% in absolute F1 score. So now state of the art in this year is 60% for Genia 2011. Importantly, we also provide first results on biomedical event extraction without gold entity information. Empirical results show that its speed and accuracy makes it a viable approach for large-scale real-world scenarios. So this is the performance of biomedical event extraction. Now in 2020, we are in around 60% with this method. And previous methods, they used 3 LSTM, knowledge base, and augmented with 3 LSTM, convolutional neural networks, even support vector machine, which is very old. So this is an example. The top one is a text with 4 biomedical events. Although it's just one sentence, but it has 4 biomedical events. Above the text, mentions and argument rows are indicated. The bottom is our proposed encoding where D, R, and H represent the label parts for dependents, relations, and heads. So events are structured representations. An event is anchored to a trigger, a text span, which indicates the presence of an event. Each event has one or more arguments, namely entities or other events, which are assigned a role in the event. So given a sequence of n tokens, we encode event structures as token-level labels to reduce the task to a sequence labeling problem. So adopting dependency parsing terminology, we encode the label y sub I for each token as D. So D is just dependent and refers to the token and its mention type. And R here is relation, head is H is head. So 2 words, dependent and head are related by relation. So you see here that we give it to BERT encoder, then we have our representation, we concatenate them, and then we have this triple. It could be single task or it could be multitask. So it's an end-to-end biomedical event extraction and is broadly applicable to event extraction and other tasks that can be recast as sequence labeling. The system's strength comes from joint multitask modeling paired with multi-label decoding, which aids interdependencies between the tasks and is superior to alternative decoders based on strong contextualized BERT embeddings. And it is fast and achieves state-of-the-art performance in Genia 2011 without need of any external tools for features and resources such as knowledge bases. And it works very well across event types.